So our next speaker is Stu Hutchings, who is a veterinarian and has a long association with TB eradication. He's currently Group Manager of OSPRI, and his team is responsible for program design and management of TB in both livestock and wildlife.
Good afternoon. Some would say that having an ambition to biologically eradicate a nationally significant bacterial disease that involves landscape scale control of a mammalian wildlife host, the possum, across nearly 8 million hectares of New Zealand wildlife bush is pretty crazy and ambitious. I'd say that it's not crazy, but it's probably quite ambitious, so we'll see how we go. So OSPRI is a company, it's a charitable limited liability company. It's jointly funded by the government, 40%, and livestock industries, dairy, beef and deer, the other 60%, and has two core programs. And one of those is NATE, our National Animal Identification and Tracing System, and the other one's the TB-free program. So what I want to do today is just talk through some of the aspects of the TB-free program that have led us towards this goal of eradication of bovine TB from New Zealand. So I think we've got to always remember with these things that TB has a really major dramatic social and economic impact on the farmers that actually get the disease in their livestock. And that really becomes our core driver for what we're trying to achieve here. And as we get further and further through our strategies, we're finding that that social impact especially is becoming more and more significant. So the key aspect that makes this disease so unique in New Zealand from a lot of other countries that have bovine TB is the relationship with this introduced mammalian species, the possum. So the transmission technique is kind of unique. The possums become infected with the TB, they maintain it in their own population in the wild, and then as they become sick, they migrate out onto the pastures and are quite dozy. Cattle and deer are really inquisitive species. They'll come and investigate, they'll sniff them, sometimes they'll even pick them up, and that's that aerosol transmission between the two of them that causes that initial spread. So when we first created the link between possums and cattle, at that stage the degree of infection in our wild possums was quite small, and you can see here that primarily it was focused around the west coast of the South Island. Then over the next few years it spread further and further into the areas of habitat that we have now and equated to around 10 million hectares of New Zealand land that was infected in the possum population. So one gory picture only, I promise. So the disease manifests quite significantly in cattle. This is a young heifer, only found last year. The real concern about this one is actually it was from a raw milk supplying herd. So impacts of that can be still quite significant. If we look, we've had TB in New Zealand for around 100 years. It was actively managed in the 1950s, quite a significant zoonosis at that time prior to pasteurisation of milk, where children especially were picking the disease up. What happened at the time, the government, we focused on just livestock control. Government of the day put some money into the system. It actually reduced the amount of infected herds quite significantly, so they stopped the funding. What resulted from there was a major significant increase in number of infected herds up to a peak of about 1,700 in the mid-1990s. What that did is drive the farming community to want to be involved in their own control program, and so the initial strategies for control in New Zealand were established. And from the year 2000, there's been significant co-funding around the control of that disease, down to the point where we're now sitting around 43, 44 herds as of June last year. So there's been a bit of an evolution of control over the time, really that have been demonstrated through 4 progressive strategies leading towards the one we're in now. So the first one just created some stabilisation. The second one focused on control in our livestock herds, trying to drive it down to an internationally recognised period prevalence. The third one said, we've recognised that we've got this problem in wildlife, let's change the focus away from a livestock system and focus on trying to remove it from wildlife and actually eradicate it and prove that concept of eradication, and then now moving on to this final stage where we're trying to eradicate the disease entirely from the country. So the previous goals around the plan were that we picked just 2.5 million hectares of the 10 million that were initially infected and said, let's focus on proving the concept of eradication in those areas, and the remaining areas will just focus on maintaining or buffering the ones that remained. That program worked really, really well. We reduced initially the level of infected herds down to 41 as of February this year. We were doing about 4 million cattle TB tests a year, and we eradicated 1.6 million hectares of that wildlife area with TB. That was much faster than what we'd initially proposed in the strategy, and it was backed up by a whole lot of good modelling work and good research. So on the back of that, we had a TB review in 2016 with all the associated funders and interested stakeholders, and the concept was put forward then, let's actually think about total eradication of this disease. So there was a lot of modelling done, there was some funding reviews done, there was a review of the science and research, and all of that led towards the conclusion that this was a feasible proposition. So the story that we've told so far is said that there has been a positive correlation between the amount of money that you spend on wildlife control, which you can see here, and the number of infected herds. So it's a slide I like to show all of the time because it shows that we've got this really positive correlation and the system actually works. This is another way of indicating what's going on. You can see here in the year 2000, massive clusters of infected herds sitting around 700, primarily focused around our wildlife infected areas, down to June last year where we've got very minimal amounts, only 12 in the North Island, some clustering on the west coast and Otago, but significantly reduced. So this has led us towards our new goal. So the aim here is biological eradication by 2055. So that's the primary target that we're focusing on, but it's got two key milestones. First one of those is freedom from our livestock, so our cattle and deer herds by 2026, and then freedom from the possum population, which is the significant one because you're removing the disease from the maintenance host by 2040, and that's the one that's the big bold target. So we do this through the same methodology that we've always done, which is a combination of pest control through the possums, disease control in our livestock farm, so identifying disease, doing intensive management, removing the infection from the herds, and movement control, trying to prevent movement of infected animals from farm to farm, only allowing them to go to slaughter. So if you compare the two methodologies, you can see here that in the previous strategy, the green areas were the 2.5 million hectares that we were focusing on eradication. The orange were buffering and protecting these areas from the ones that had maintenance control. That's moved across into our new plan where we're saying all of that area is a focus on eradication, but we've just broken it up into 5-year chunks of time towards which we'll achieve that. So how are we going to do that? So if we look at the livestock target first, really what we're doing is changing our livestock surveillance approach away from a generic area-based TB testing policy broadly across the whole country to focusing our risk in herds around 3 key risk indicators for the disease. That's location, where does a herd reside in relation to the wildlife infection? Its history, has it had infection before? Because we know that herds that have been previously infected are likely to develop disease again. And movements. Animal movements happen all over New Zealand. TB disease is quite hard to detect by our tests, so we run the risk that the disease will move sometimes undetected. So the risk-based testing, what we're going to focus on there is just the standard reduction of our testing policy associated with our wildlife control program. So as we begin to eradicate areas, we can reduce the test policy in those. We'll reduce the amount of tests being done in our surveillance areas, those that don't have wildlife risk associated with them, and we'll start to focus our testing on those animals that are moving that carry disease risk. So if you look at the proposed changes over time associated with the wildlife control, you can see that the amount of areas that we have a testing intensity on will actually shrink through the next 10 years. So if we now look at the second target, which is the TB eradication from possums, so what we've done there is we've focused our control efforts around creating what we're calling TB management areas. So we've built about 120 of these, and all of them have similar habitat or stage of control or biological risk factors associated with them. And we've built mini strategies for every single one of these areas through to an eradication target. So when we previously were doing our wildlife control, we ran a pretty formulaic response. What we would do is we'd do an initial control, suppress the possum population down to a low density, maintain it at that, about 2% RTC, which is about 2 possums per 100 trap nights of effort. We'd keep it there for upwards of 5 or 6 years and move into a pre-eradication phase. In that phase, we'd go out and we'd survey other species like pigs or ferrets or deer that often would pick the disease up and were quite good indicators of what was going on in the possum population. These final eradication surveys would then gather all that data up and then put that towards an indication of whether we were free from the disease or not. That's quite a long program, upwards of 15 years for each land area. So it was reasonably inefficient and we wouldn't have been able to achieve our eradication target. So the new strategy approach is then saying, well, let's take each one of those TMA areas and actually do a bespoke program for each of them. So some of them we can do that standard control and survey approach, but some of them we're far enough along with our control that we'll just go and do the surveillance, work out where it's sitting at in terms of its freedom from disease, and then potentially declare it free. Some will do a survey first, it'll tell us there might be a bit of disease, then do a control program, and so on. So each one working efficiently towards maintaining our goal. So when we're trying to prove freedom, what we're doing is we're starting with what we call a prior probability, and that's dependent on the level of control that's happened. Basically, the premise is if you suppress the possum population so low that possum A that has infection is going to die before it infects possum B, the disease will disappear. So it's a very simple paradigm, but that's the premise that we work off. So if we measure our control efforts that we've done, we can work out what the prior probability of freedom is. Then we come along and we do our surveillance of the other species, and they can include possums, and then put that through a Bayesian statistical model to try and calculate our probability of freedom, and we set a target of about 95%. If we get to that 95%, we say that's significant enough probability the disease is gone, declare the area free, and shift our funding to another area. So the model is quite complex, but basically it's taking inputs of data that we gather all the way through. So the control data we've done, the surveillance data that we've gathered, what livestock information that we've got from herds in and around the area, the spatial analysis of amount of surveillance that's occurred within that landmass, put that all into the model, and basically it'll spit out a probability of freedom. We then sit down with a panel who will then qualitatively assess that according to the risk factors of what happens if we've got it wrong, so what's the cost implications, and combine those two together to make a decision about whether we're going to call that area free or not. So basically, using those systems, we believe that we can maintain and get to our target of biological eradication by 2055. So you'll notice that there was a 15-year gap between the freedom from possums in 2040 and biological eradication, and that's really to allow a clean-up period because there will be wildlife hosts like deer that still have the disease out in the bush, and we're not actually actively controlling those. So what we need to do is allow ourselves a buffer period for those as a secondary host to die out and eventually get rid of any of those final pockets that we might have. Thank you very much.
Questions? Mick was first. Then microphone's coming.
Sort of an obvious question, really. I mean, we've just been listening to talks about predator-free 2050, where the possum is one of the focal species. And the aim there would be to eradicate possums completely from New Zealand by 2050. Are you working together with predator-free 2050 in the planning for possum control and hopefully eradication?
Absolutely. I mean, it's a given that if possums disappear, the disease disappears from our perspective. And historically, for us, we've only been able to focus our efforts on those areas of New Zealand that have had possums with TB in them. So it's been a disease control program rather than a possum control program. So, but with being able to work collaboratively with the Predator Free 2050, and we've been doing a lot of work collaboratively with DOC with the Battle for the Birds as well, then obviously we get leveraged benefits across both, and we can increase that biodiversity gain.
Question up the back.
Björn Obach from Ag Research. In 2015, there was a paper from a Chinese group where they used SP110, so nuclear body protein, overexpressing that in the macrophages of transgenic cattle and rendering those TB resistant. It wasn't a complete resistance, but a very strong partial resistance. So does that kind of approach feature in your long-term strategy at all, especially given the fact that we could now do this with genome editing without transgenic approaches?
So we do spend about $2 million on research every year as part of our program. A lot of that research is actually focused on ecology of possums and understanding about how they behave in the wild, and toxin research and diagnostic research. But there has been some work in New Zealand done on resistance in deer, farm deer, to Johne's disease and TB, and there has been some indicators, but in terms of having a component that's going to have a significant impact on a disease program in the time frames that we've got, there's probably better methodologies that we could employ.
Final questions.
Thanks, Stu, and a supplementary question to Mick. So, a crazy and ambitious challenge to OSPRI. Why don't you put your $53 million a year into Predator Free 2050, achieve your goals, achieve Predator Free possum goals earlier? So how are these going to come together in your mind, and, well, can they come together?
Yeah, good question, and obviously one that would certainly be a great outcome. I guess I have to give you a slightly political answer, in that our funding stream comes from the farming community because they have a vested interest in managing the disease in their livestock. So obviously if we were able to convince our funders and shareholders that the same outcome, which it can be achieved by doing that in a collaborative or total sense, then I guess, yes, we could get there.
Thank you, Stu.
Thanks.